There are a number of scenarios for why you might want to edit external configuration files at runtime. The first is you may want to be able to modify the settings for testing. Another is that you want to have control over the security settings or URL mappings at runtime that govern the site navigation. Or maybe you want to be able to administer remote servers. In addition, you can use external files to make it easier to switch between multiple groups of settings by switching the path to different external files. This is similar to the use of include files in other contexts. It just gives you a lot of flexibility in how you make changes to the site, and you have control over whether it causes an application restart or not. So let's see how this works. In this example, I'm going to move the app settings section to a separate text file. I'm displaying that file. It's called settings.config. It needs to have the .config file extension, but I can name this whatever I want. And as you can see, I've included the page title key within that section. Notice that this is a configuration file fragment. I don't have to have the root or any parent elements. This is just a fragment that is essentially going to be inserted into the web.config file. So I'll open up the web.config file for the application, come down here to the app settings section, and comment this out. And then I've also uncommented this app settings element. This is different from the full app settings section because rather than having child add elements, it doesn't have any children at all, but instead uses the config source attribute and specifies the name of the settings.config file that I want to use for those settings. This is what you need to do to use an external settings file. All right, I'm going to go ahead and run and load the app settings file. It prompts me to save my changes, which I'll happily do. And I'll create a new session variable. Save that in the session state and display the session variable. Okay, all is well with my session state. Now I'll create a new app setting. I'll create this one with the name AppDev and give it a value of ASP.NET Rocks. I'll go ahead and save that setting. All right, so I've changed the app setting, and I'll redisplay the session variable, and notice that it still contains the contents. So I haven't done anything to change or affect the session state for the current user. I'll list all of the app settings, and notice that we have the settings that we expect, the existing page title and the new AppDev key. All right, I'll go ahead and close the browser. I get prompted. This time, it specifies that the settings.config file changed. I'll go ahead and reload that. I'll first notice that nothing changed within the web.config file. But if I go over here, I can see that my new key was added to the external file. Because this is an external file, by default, ASP.NET is not monitoring it for changes. And so it doesn't see that there's a change, and it doesn't restart the application. This is the default setting, but if you want to change it for all applications on this computer, you can go into machine.config and change the Restart on External Changes setting and set it to true. So you have control over the process, but that's a machine-wide setting. The app settings and connection string sections in ASP.NET have special support because so many applications need to use connection strings and have a place to just kind of dump individual application settings. But there's literally hundreds, if not thousands, of other settings that make up the .NET framework. So that's why the .NET Framework has support in the system.configuration and system.webconfiguration namespaces for reading and writing those sections. These built-in settings are stored in what are called standard configuration sections because they are supported by classes in the configuration namespaces. To access them, You can use the Configuration Manager and Web Configuration Manager objects to get a configuration object, then use the specialized section object for that section. That's similar to other code that we've seen. For example, suppose that you need to find out whether the current application is running in debug mode. More specifically, you need to find out whether the debug attribute of the compilation element in web.config is set to true or false. You could read and parse the XML within the web.config file, but there's an easier way. You can use the Configuration API to get a configuration object in order to read the setting. Let's see how you can use that within an application. Here's that debug setting in the application's web.config file. As you can see, it's currently set to true. So I'll go ahead and run the page. And I can click on the Get Debug Setting button here, which reads the setting and indicates that the application is in debug mode. I can toggle that setting, and it indicates that debugging has been set to false and saved. If I go back over to Visual Studio, I get the little pop-up saying that web.config is changed. Do I want to reload it? I do, and debug is now set to false. I can come back over here, toggle it again, read the value once again, and I can see that it in fact was changed back. So let's look at the code that makes this happen. Here's the event procedure that reads the value. I start out by instantiating an object of type configuration because that's what I'm going to use to get access to the section. Because this is a web.config file, I'll use the Web Configuration Manager's Open Web Configuration method, passing in the name of the application. Now, because I'm passing in the name of the application, that implies that I can open up other web.config files. And that, in fact, is the case. But in this case, I'm going to open up the current application's web.config file, and then instantiate an object of type compilation section. This is a standard configuration section, so the Configuration API has support in the form of objects for getting access to that section. Then I'll use that config object's getSection method, passing in the XPath expression that identifies which section I want to read. GetSection returns an object of type system.object because I could request any kind of compilation section, so I have to cast it to the specific type of section that I'm reading. Then, once I have that compilation object, all I need to do is just read the value of the debug property, and I'm done. And I display that value on the page. Changing the value isn't a whole lot different. So here's the code behind that toggle button. I once again have to get a reference to the configuration section, as well as a compilation object of type compilation section. And then once I have that, I can just toggle the value of that debug setting, and that updates it. But there is one little bit of a twist to this. It's possible that the section could be locked. So I can use the isLocked property of the section information property of that compilation object in order to check to see whether or not it's locked. In machine.config or web.config, there could be settings that prevent that value from being updated. So, as long as it's not locked, I can go ahead and save the value. This actually writes it to disk, and then I can display what happened to the user. Otherwise, if it is locked, I can display the current setting and let the user know that it wasn't able to save it. Because this is a standard section, there's a lot of support for getting access to those values, so you can get access to just about any standard setting for any type of .NET application. Is that all there is to the Configuration API? Emphatically, no. There's a whole lot more that you can do with the configuration settings in .NET, and specifically ASP.NET programmatically. For example, the configuration namespaces have rich support for getting and setting collections of settings, manipulating various settings in various config files, and doing way more. And if you need to go outside of the box and store custom XML formatted data in a config file, you can create your own custom configuration section. In fact, if you dig deeply enough into .NET configuration files, you'll very quickly discover that Microsoft has implemented .NET config sections using the same classes available to you. The sky really is the limit, and the good news is that the entire configuration infrastructure is at your service if you're willing to write actually surprisingly little code. One of the issues with configuration files is that eventually there's an excellent chance that you'll need to store sensitive information in the file. One common example is if you need to store the username and password for getting access to a database within the connection strings section. Fortunately, IIS and ASP.NET make it very difficult for a casual user using your web application to get access to that config file. But any users that have read access on the server may be able to get at and read those configuration files. And of course, web applications have security vulnerabilities. That's just a fact of life, unfortunately. And so an attacker could penetrate your security and get at that information. But fortunately, ASP.NET makes it quite easy to encrypt sections of .config files. You can do it programmatically using the protected configuration features. The Protected Configuration Provider class in System.Configuration is the base class for all protected configuration providers. It uses a protected configuration for encrypting and decrypting sections of the web.config file, such as the connection string section. The nice thing about this is that once the section is encrypted, ASP.NET, or in fact any .NET application, will automatically decrypt the data when it needs to read that particular setting. You don't need to do anything within your application to do that. So it all happens automatically. The .NET Framework includes two protected configuration providers that you can use to encrypt a configuration file. The first one is the DP-API Protected Configuration Provider, or sometimes called DPAPI Protected Configuration Provider. This uses the Windows Data Protection API to encrypt and decrypt configuration sections. And it uses the Windows Data Protection API, or DPAPI, to encrypt and decrypt configuration sections. DPAPI uses a machine-specific key that can be used to encrypt data only that is located on the current machine. This is useful for anonymous services, but it provides less scalability than the other provider. And the other provider is the RSA Protected Configuration Provider. This provider uses the RSA Crypto Service Provider that is part of the encryption services that are built into the .NET Framework. It's used to encrypt and decrypt configuration sections using public key encryption, which is required for encrypting and decrypting the information that will be used on multiple computers. So if you need to move this application between machines, it'll be much easier for you if you use the RSA Protected Configuration Provider. These providers are registered in the Config Protected Data section of the machine.config file, so they're available to all .NET applications that run on this machine. Here's the machine.config file opened up within Visual Studio, and it's displaying the config protected data. This shows that the default provider is the RSA Protected Configuration Provider. But you can use either of the providers that are defined, and like other provider configuration sections, it has a friendly name of the provider as well as the class within the .NET Framework that implements that particular provider. Because this is in machine.config, it's available, as I mentioned, to all applications on this machine. And you could conceivably develop your own provider and install it here in machine.config. The sample code that we're going to look at uses the Data Protection Configuration Provider, which uses a machine-specific key for encrypting and decrypting configuration sections. If you're running your site just on a single server, this is really all you need. But you may want to consider using the RSA Protected Configuration Provider if you're using this within a web farm, because that makes it easier to deploy the keys to other servers. What we're going to do is encrypt the connection strings section, because as I mentioned, very often this section has sensitive information. So I'll go over to the application's web.config file, and you can see that we have just a typical connection string section, a couple of connection strings that are defined, along with the text of the connection string. So we want to encrypt that information because it's sensitive information. I'll start by running the application. I'll right-click here and view the encryption page in the browser. And I'll click the Retrieve Connection Strings button. This just uses the Configuration API features in order to read the connection strings that are available to this application. Now what I'm going to do is toggle encryption for this section. It indicates that now the section is encrypted. And if I retrieve the strings again, well, wait a second. Nothing's encrypted. Well, actually it is. Let's go back over here. Web.config has been updated. And if I come back to the connection strings section, notice that I no longer can see the connection strings. Instead, I have a new attribute called Config Protection Provider, indicating that I'm using the Data Protection Configuration Provider. And then I have a new child element called Encrypted Data and a long cipher value that is the encrypted version of that section now. Well, okay, wait a second. Let me go back into my application, but nothing's encrypted. Well, the really nice thing about this is that once the section is encrypted, I don't have to do anything different in my code in order to decrypt the data. When I read the data, as I did when I clicked on the Retrieve Connection Strings button the second time, ASP.NET saw that it was encrypted, decrypted it for me, and I'm all set to use the connection strings. It's really nice features for using this encryption within configuration files. Let's look at the code that makes this happen. Here's the code behind that toggle encryption button. As usual, when we're working with configuration files, we have to open up a reference to the configuration, and then, in this case, get a reference to the connection strings section. So we do that using the getSection method of that configuration object. In order to encrypt the section, all we need to do is check to see if it's protected. And if it is protected, then we just call the unprotect section, which decrypts the data. Otherwise, if it's not currently protected, in other words, it's not encrypted, we just call the protect section method, passing in the name of the encryption provider that we want to use. In this case, we want to use DeepAppy, so we use the Data Protection Configuration Provider. Then, just like any time I make any sort of changes to configuration files, I call the save method of the config object, and that actually writes the changes to the web.config file. And rather than just writing a single setting or creating a single element, it removed the existing connection strings section and changed it to include the encrypted information. And then I indicate whether or not the data is now protected. Here's the code that retrieves the connection strings. Very straightforward. It uses a string builder to concatenate the list of strings, gets a reference to the connection strings settings collection, and then, as long as it gets any connection strings, it loops through the strings and just reads the different properties, in this case the name and the provider name, as well as the connection string for each of the connection strings that it finds. Notice that there is no code here for doing any kind of decrypting. And this is the exact same code that executes whether or not the section is encrypted or not, because the .NET Framework and ASP.NET take care of doing all that work for me. And the rest of the code just displays a string indicating if it didn't find any connection strings. Very simple and straightforward. Another nice feature of encrypting configuration sections is that I don't need to do anything different if the section is included in an external configuration file. So I'll go back over to web.config here, see that my connection strings section is still encrypted. I'll rerun the application, and I'll toggle encryption. Okay? Now the section is unprotected. I can go back over here. Web.config has changed, and I have my connection strings settings back to normal. What I'm going to do now is I'm going to comment out that connection strings section and instead use an external file. Here's that external file. Notice that we have the same two connection strings defined here. We've just put them into an external file. All right, I'm going to shut down the old application there, and then I'll rerun it. I'll retrieve the connection strings. So as you can see, we get the same connection strings as we got previously. And I'll toggle encryption. It's now protected. I can retrieve the connection strings. We get them as clear text. And once again, when I go back over to Visual Studio, it tells me that the connections.config file has changed. I'll go ahead and reload it, as well as the web.config. And now this connection string section is encrypted. So the overall effect of using an external file is the same as though the section were contained within the web.config. One of the things that you'll often need to do is move a website from machine to machine. You might start on a development server, move it to a staging server, and then move it finally to a production server. In that kind of scenario, you'll want to use the RSA Protected Configuration Provider. And in order to do that, you can use the command line tool ASP.NET_RegIIS to create key pairs and to import and export them between machines. The .NET documentation has a lot more information about actually doing this. The reason you would want to use the RSA Protected Configuration Provider if you need to move the website is that if you use the Data Protection Configuration Provider, it stores the keys deep within Windows. So you have a little bit more work to do in order to move the website. You would have to decrypt the connection strings before you move the configuration file away from the old server. Otherwise, the new server is not going to be able to read that data, and there's really no practical way at all of getting access to that information. And one note about the data protection provider. By default, those keys are stored at the machine level. But there is an option to store different keys for different users' accounts. With the data protection provider, keys are stored by default at the machine level. But there is an option with DeepAPI to store different keys for different users' accounts. This is really useful if you're going to be running multiple applications on a single server and don't want them to share a common key. But you do have to jump through some hoops in order to implement this with a web application. And you can find a lot more information about that within the .NET Framework documentation.